Okay. Yes, yeah, it's true. I wanted to see that there.
Okay. Now, basic network components. We have four basic network components at your level that you need to know. I need to know the terms. So whenever it is being mentioned, you should be able to know what devices are, what hosts and media and the rest. Now, I'm using this topology that we have here to
Okay.
explain, I'm using this topology here to explain these networking components. Now, first of all, we have what we call hosts.
Host.
Hosts, yes,
Okay.
hosts are, I'll call them computers. As I said before, the computers is not just your personal computer like your laptop. Printers
Mm.
are computers. Cameras, uh,
Okay.
yes, they are computers. And alarm and so many other transducers, scanners, and all of that. They are computers as well because they can function. They they function within the definition of a computer because computer definition of a computer is says that any electronics device that can receive data, process it, give output, get input, and all of that, do all those stuff with data. So it means that PC alone is not just computer. Others are computer. Now, hosts are computers that are directly connected to the network devices. Maybe I will start from this first, telling you what network devices are. Network devices are hubs. They are hubs. I will explain hubs, switches,
Hello?
yeah,
Okay, okay.
and routers. So these are basic network devices that you should know.
Okay.
Now, looking at this place now, this is hub. It's just the symbol. It's not the real structure of hub. This is a switch. Maybe might need to show you the picture if I have it here. I don't know whether I have the picture of switch hubs. I'm not so sure if I have it here. Um, anyway, if I get it, I will. I have it, but I don't know where it is. I can't actually pin it out. Okay, that was by
Okay.
the way. So, hubs and switches, routers as well. They are what we refer to as network devices. Sometimes they can be referred to as network nexus, like
Jesus.
nexus. They are the central. These are the central place that connects hosts together. Now, look at this place now. This hub is directly connected to this PC, is directly connected to
Yes.
this laptop, is directly connected to this PC. So all these PCs, laptops that are directly connected to the network devices are referred to as hosts. And another property of hosts is that they always have IP address. Let me put it that way. Can you hear me?
I can hear you. As in the test, I can't see the test on the screen clearly.
On the screen, the face.
The, yes, I can see the diagram, but the text beside it and the other side, I can't see them clearly.
Oh, I don't really know. Okay, maybe I'll. Um.
The text from the diagram, I can see most of them.
Okay, but all these things I wrote, like these things,
The one you wrote,
they are not
I saw
clear.
that one.
Okay.
Yeah, I can see the one you wrote, but the other side from towards my left hand side. Is what I can see. I don't know if
No,
that
no, no. All
that's
those ones are
fine
not really
there.
important like that. Just if you
Okay,
pay
okay,
attention to what I'm explaining, they are all
okay,
there.
okay.
So now
Let's
I've
go.
explained what network devices are. I gave you examples: hub, switches, and routers are network devices. Then I said host. One of the properties of host is that it always have IP address. Let me put it that way at your level. It has IP
Okay.
addresses and it is directly connected to the network device. So when you look at this
Okay.
diagram now, this guy, this PC is a host. Why? Is because it's directly connected to the hub. This laptop is a host. Why? Is because it's directly connected to the hub. This one too is a host. You know that this is a switch, it's a network device,
Switch.
right? And
Uh-huh.
it's directly connected to server. So this server is a host. It's directly connected to printer here. So this printer is a host. Do you get?
I can hear you.
Yeah. So now I've explained hosts, I've explained network devices. Now peripherals are also electronic gadgets or networking gadgets that are connected to the host. Now, at your level, I will tell you that they don't have IP addresses. Just take it that peripherals are gadgets, electronic gadgets that are directly connected to the host, not to the network devices. It means that this printer is a peripheral, while this printer is a host. You see the difference now?
Yes.
The both they are printers, but this one is a peripheral,
The
while
peripheral
this one is a host.
is a
Why?
host.
Is because this one is directly connected to network device. This scanner
Mm.
is a peripheral.
Peripheral.
This webcam is a peripheral
The peripheral.
because they are connected to the host. Now, that's just the first thing. Now, remaining the last one, which is network media. The name media is a means. Media is just a means of the means through which data are being propagated from one end to another end, or from one point A to point B. And can either be the media can either be um, cable, or we have cable, we have, or you can call it wire and wireless,
Wireless.
wired and wireless. Now you can actually from connect network devices or hosts through cable or through wireless. So now you know that there are some printers that are wireless they can connect to the network
Mm.
wirelessly. So it doesn't matter whether it is wired or wireless. There is a means, and we have two means of connecting. Is either you are is
Okay.
wired or wireless. Okay. I will be taking. I am done with host. I don't think I'll come back to it again. I won't come back to this again. I want to talk about media. Now, in media, I say we have wired and wireless. That is wired and wireless. In wired media. Sorry, I have to close this. Hold on. I have to open it again. Okay. Sorry, I need other things too, but for now. Okay, now in what I say that in media we have wireless, we have wireless, we have
One wire.
wired. I can call it cable. Now, in cabling, we have different types of cables that we use. One, we have optic fiber. We have optic fiber. We have coaxial cables. And we have twisted pair. We call it TP. So these are three different cablings that we use in networking. Now, in fiber is a type of cabling as we have here. Now, there is this basic structure of fiber. Basic structure of fiber is that it has core. Look at this place. Here is core. That's core. Here is
I'm not seeing your marker.
Okay, this is core. Okay, let me do it well. This is it's already specific core. You see where it's pointing?
That's what I'm saying. I can't see the text very well. I can't see this one clearly.
Okay, this is the core. Can you see the picture?
Yes.
Yes, the interior part of it is what we refer to as the core. Now, the surrounding part, which can be plastic or glass, is referred to as cladding. It's pointed. See the arrow where it's pointing. And the last one is coating. Sometimes it can be called buffer. Although this is just basic structure of fiber. We have it could be more complex than this. But you just know the basic one, core, cladding, and buffer. Then you should know that the core is the place. Okay. Let me put you back. Okay. Back to this. Fiber. Can you hear me?
I hear you.
Okay. Now just know that fiber uses light as a means of propagating data. Why these two uses electrical characteristics, electrical impulse, electrical impulse to propagate data. This is uses light. Now, back to the fiber. Now, that light that it uses to propagate passes through the core. It passes through the core, that is center place. You should just know that. Now, we have two forms of fiber optic cable. We have multi-mode and single mode. There are differences. Now, one of the differences is that in single mode, what I mean, in single mode, the core, I've explained what the core is. The core is smaller to compare with multi-mode. In multi-mode, it is larger. Now, in single mode, there is less dispersion. Like you see this, the way light is scattering. You see the way light is scattering here. So there is more light dispersion, greater light dispersion in multi-mode than in single mode. Now, single mode is suited for long distance application. When you are connecting cable for a very long distance, there is this thing you need to know about. We call attenuation. Have you heard about the word before?
Yeah, what the meaning?
Yeah, attenuation is, I would say, it's just the reduction in the signal strength. reduction in signal strength as when the data is moving from one point to another point. Just as if you shout, there is a limit or a distance your voice can go, depending on how you are shouting or how you are talking. So it's the same thing with propagation of data in cable. There is limit to where the data can reach. But okay, and there is always limit for every cable. Now, in this cable, sorry, in this cable, the attenuation or the limit of attenuation is 100 meters in twisted pair. In coaxial cable, I'll give that as assignment. You check this on the internet. But fiber, in fiber, the attenuation varies. The attenuation length varies. Like in single mode, the attenuation, the single mode can transmit data as far as 10 kilometers and above. It can go as far as 10 kilometers. You know that when there is, when you suspect that a signal will get lost, just as I told you here, if twisted pair is 100 meters, that means if from here to here is 100, that means at this place, you need to put a repeater. We'll call it repeater. You need to put in a repeater. Repeater. You need to put in a repeater here. If from here to here is 100, you put a repeater so that you can go more than 100 if you are going far. So if from here to here is 100, you need to put a repeater here like that. Repeater is just something like a device that can boost signal strength, or that can extend signal from one point to another point when you think that the signal is diminishing. So, and you should know that hubs, switches, routers are repeaters ordinarily. So, see back to fiber. So, the length, the distance, the uh, single mode can go up to 10 kilometers. Why this one can go up to 500? This one can go up to 500 to can go from 500, sorry, 500 meters, 500 meters to anything, maybe 5 kilometers, depending on technology, because there is a lot of changes in technology and it grows every day. So, and again, in single mode, the light that single mode uses is lesser light. While in multi-mode, the light that it uses is LED light. So these are basic differences between single mode and multi-mode. There is more. We have more and all of that, but at your level, I might just stop at this point. So now, still on this, I'm assuming that I'm done with fiber. Now, coaxial. Coaxial cable is just the same cable that you use your TV from your satellite dish to your decoder. That cable is what we refer to as coaxial.
Hello?
Yeah. Can you hear me? Can you hear me?
I can hear you.
Okay. So
Yes,
see
sir.
example of coaxial cable. You see that there is this metal inside, and this one is one plastic covering, and this one is wire gauze. You see this wire gauze is actually used. This wire gauze The function of or the essence of this wire gauze is to provide resistivity of that cable to interference. Now, this thing you need to know about that data in a cable can be interfered with by these two basic things, by your electric field, sorry, by electric field and sorry, data in your cable can be affected by electric field and high frequency wave. By high frequency wave. High frequency wave can be a microwave, although microwave is the wave that is more common in our environment. Almost everything, like your radios. What I mean by radios, I mean all those stuff you see mounted on the mast by
Yes.
GSM bodies and all of that. They are using microwave, as in the frequency they are operating with is microwave. You understand what I mean by microwave? You know, in wave spectrum, we have light, we have infrared, we have X-ray, so many of them. So
Yeah.
most of these technology that we are using in electronics, they are majority of them are using microwave. And you should know that microwave and other high frequency waves can interfere with the data in your cables. So it is very advisable when you are running your cable, you should avoid these two things. You should avoid electric field and high frequency wave like microwaves. Now, when I mean by electric field, I mean when when a cable that is carrying current is passing, there is this field around it. So that field can affect your data cable. If your data cable is somewhere here, it will affect your data that is passing through it. So whenever you are running a cable as a network administrator, network engineer, you are meant to avoid electric field as much as you can. Electric field and microwaves. Now you might ask me, how is it that all those radios on the mast, they still use cables to run from there down?
Hello?
Yeah. Can you hear me? Hello?
Hello?
Yeah, I can
I
hear
can
you.
hear you.
Okay. You might ask me, since electric field and microwave affect cables, how come that people see run cable from the through the mask, like all those radios and all of that? Microwave affect them, so why do we see use cable on them? There are special cables that are used on those masks, and all those cables have this kind of this gauze. I'll talk more about that. So I'm just trying, in essence, is that I'm just trying to explain to you what this wire gauze does. It helps to shield your cable from interference that are coming from electric field and microwaves. It's not a guarantee that the interference will not have effect on your data. Only that it can still give you some privilege. It doesn't mean that when you install thunder arrestor in your house or on top of your roof, that thunder will not strike and enter your house. It's not a guarantee. So, as much as you can, try to avoid, excuse me, electric field and microwave. So, especially when you are running a conduit wiring, of course, that's the professional way of running electric network, as in computer networking cables. Excuse me. So, except in a situation whereby you know you cannot avoid running electric cable and data cable. Sometimes when you're running a conduit, it might be that the only way to pass your data cable will be the same hole that the electric cable is passing through. So in such a case, you need to use a special kind of cable. I'll talk about that when I come to twisted pair. But so far, it's just coaxial. I've talked about fiber
Okay.
optics. So I am done with coaxial. So the next thing I want to talk about is twisted pair. Now, twisted pair are of two types, two basic types. There are more, but I won't go into all of that. Now, twisted pair, we have, let me put it this way. In twisted pair, uh, we have unshielded pair. We have UTP, unshielded pair, unshielded twisted pair, and STP, STP, shielded twisted pair. Now, what you are looking at this place now is UTP, that is unshielded twisted pair. That's what you're looking at. Why did I say so? Because it does not have this kind of wire gauze. So the ones that have this type of wire gauze are called shielded twisted pair. Do you understand?
Yeah, I'm following.
You get it now, difference between the two.
Yes, sir.
Unshielded twisted pair and shielded twisted pair. Okay. Now, let me go back to where I started from. I started from computer, basic networking components, where I talked about hosts, peripheral, network devices, and media. I've thought about all those ones. So by this time, you're supposed to have known what is host, peripheral, and devices, network devices. Now said
Oh, yes, sir.
network media, we have wire and wireless. I've thought about
Why
wired. Wired
yes.
are of three types. I've explained fiber, two types forms of fiber, single mode and multi-mode. And I explained coaxial. Then twisted pair, they are of two types, shielded and unshielded pair. I've
Yeah.
explained their differences. Now, if someone asks you about this, you'll be able to explain it. I'll come back to wireless later on, but let me finish up with cables. Okay. Now, shielded on this twisted pair. Let me go back to our um, cables. Now, all the cables in the world, they all have terminator. As in, when I mean terminator, I mean the end point. Look at this
Yeah.
fiber. This fiber, there's a terminator here. That's the end point of it. Like even your laptop that you are using, the charger that goes
Mm.
inside your laptop terminates
Yes,
that
yes.
cable. Yes,
Mm.
some end cannot go to another end of some laptops, depending on the mount. So we have different terminators and different sizes. So in the same case, in coaxial cable, we have a terminator. Or for coaxial cable, we have terminator for fiber, and they all have names, but I don't know their names. The one I'm after is twisted pair. Twisted pair, the terminator of twisted pair, we call it RJ45. We call it,
RJ45.
yeah, RJ45. Look at it. This end,
Okay.
sorry,
Mm.
this terminator is what we call RJ45. Sorry, we call it RJ45. Now that's for data uh, cables. Now we use this RJ45 when you are dealing with data. Now you see some phones like the ones we call intercom phone. All those ones use RJ11. RJ11. The terminator for those ones are smaller. And RJ45 can take 4 pairs of cable, while RJ11 can take 2 pairs of cable. So in this, when you count all the cables here, you see 8 of them. While in this, the total number of cables are 4. These ones deal with voice. Voice. This one is for voice. Why this one is for data? It doesn't mean that data cannot carry voice, but it can carry both. But this one is majorly only for voice. RJ11. Now, knowing what terminator is, and also seeing that the cables are this. I said there are 4 pairs. Like they are. This is blue. You can see it. This is orange. This is brown, and this is green. And you see that in blue you have 2 blue, blue and white, and blue, solid blue. This is blue stripe, as in blue and white. Why this one is solid blue? This one is orange, solid orange. Why this one is orange and orange stripe, as in orange and white, like that, and all of them. So there are 4 pairs. Now, when you want to terminate them, there is rule. You can't just bring RJ45 and just put the cables inside. There is something we call scheme, cabling scheme. Something we call cabling scheme, as in the rule of terminating twisted pair. You know, twisted pair will have shielded and unshielded. And the scheme, there are of 2 types. We have T568A and T568B. These are the 2 schemes that we use when you want to terminate your twisted pair. So, how is this scheme like? So, whenever you're terminating twisted pair, you need to group your cables either this way or that way. In both ways, just take it in both ways, they all have brown at the end. Brown at the end. They all have blue at the center and blue at the center. And blue at the center. The only difference there is just the orange color. Orange color and green.
Green.
Yeah. And the green. And we refer to these 2 these cables as data cables. You understand more when I say data cable later on. So these are the ones that carry data. When you are transmitting data from one point to another, the ones that are carrying data are orange and green. Other ones I will explain. Other ones are for PoE. We'll talk about that one later on. Now, you know that in A, green comes first. While in B, orange comes first, as among the 2 data cables. So if green is coming first, then orange will engulf the center. You see it? But in this case, in B, if it's orange coming first, then green will engulf the center. So that's just, you need to memorize this cabling scheme. So like someone say terminate twisted pair in RJ45, we should be able to know how to terminate it. Now, when we come to the center, we'll practically show you how to terminate your cables using RJ45. You can see check that on YouTube. You see physically how it's being done. But you come. It's important that you come to the venue so that we can show you physically how to terminate your data cable. So that's that for cabling scheme. Also, you should know too that, as I said before, that this the remaining cables like okay, the remaining cables like this and this, they are for PoE. That's blue, blue.
Oh, yeah, it's not like, yeah, it's not like, you leave the old me, but I'm going to you. Hello, I can't hear you.
Can you hear me now?
Okay, I can hear you now.
Okay. So, like this webcam now, you know that this webcam would never work until it is powered from somewhere. You know that this printer will not work until it receives power from somewhere. The same thing with this scanner. You get
Yes, sir.
okay. Now, et- power over Ethernet. That is PoE. I will expect you to go and read up this thing on internet and the material we're going to give you. Power over
Okay.
Ethernet is a technology that allows data and power to go the same cable. And because of that, all technology that employs power over Ethernet, they don't need power like webcam. If some cameras do not need to be plugged, as in to receive power from anywhere. So as soon as the camera is connected to the switch, it comes up automatically. Why? Because the data power passes through the switch and the data to the camera. So it doesn't need extra power source. So that's that for PoE. Now, any gadget like hosts that are PoE enabled are called PDs, powered devices. Why network devices that network devices that powers the PDs are what we refer to as PSE, power sourcing equipment. Do you understand?
Yes, sir.
So when switches, no, it's not all switches that are PoE switches. Okay, let me put it this way. It's not all switches that are PSE. There are ordinary switches and there are PoE switches that we call them PSE. It means that they have ability of sending data and power at the same time to the devices like PDs. Now we have also what we call PoE and PoE plus. We have another technology called PoE plus. Which I expect you to go and read up this. Just read
Hello.
up, yeah. We have
I hope
PoE.
I can get the material on it very well. Abi?
Yeah, we'll give you the material. So we have PoE plus, we have PoE plus plus. The only difference is that in PoE plus, there is always, over time, I just noticed that there is always something like an adapter. You see your laptop charger. Your laptop charger has a cable that you can plug to power, right? Like this, right?
Mm.
Then one now goes to your system. Now, some devices like cameras that cannot receive power enough from a switch, because some PSEs, their voltages are about 24 volts. Some are about 24 volts. Now, some cameras are about like 50 volts, 50 volt input. You know that if I have a 50 volt, 24, 24 volt cannot power this. You understand? Because it's using
Yeah.
50. So most of these devices that has, most of the PDs that have high voltage or high power, they come with what we call PoE adapters. PoE adapters. Adapters. I'm now explaining to you how the adapter looks like. Adapter has, maybe I can just check that on internet, show you that on internet. So adapters do have something. Can you hear me?
I can hear you now.
Okay, sorry. Wow.
Do you also?
Okay. So I was trying to let me get the picture of a PoE adapter for you. Okay, so look at the way it looks like. Can you see my screen? Can you
That's
see
it.
this? Yeah, so this is the way
But nothing shows up.
Huh?
Nothing shows up. Nothing shows up on the screen.
I'm coming. Okay, now you are seeing the screen now, right?
I can see it now, yeah.
Okay, now the adapter, this is the PoE adapter, the picture of it. It looks like this. So one end, like this
Yeah.
end, goes to the switch, and one end goes to your PD. See the power cable that powers the PoE adapter. Let me show
Mm.
you. Okay, look at even the way it looks like. So this is the way it looks like. You see this one now, they use this one on radio. Let me explain.
Mm.
Now, one end went to the radio, then one end goes to the switch, and it is powered somewhere. So if this is power, so when data is coming from switch, it enters here inside and passes through here with power. So that is what you do. So most of the technologies that are using PoE plus uses that adapter. PoE plus and even PoE plus plus. So you just take your time to read up that. Now I wanted to show you too what switch is. Like switches, switch, network switches. So this is the way switch looks like.
Hello?
The picture of the switch. Can you see it?
Yes.
Yeah. So you have different ports and all of that. Different ports and the rest. So that's by the way. So please just take your time and read up PoE. I won't
Okay.
go much into that. I will explain wireless later on, but not in all everything about wireless. Please, can you um
Hello?
yeah,